Hello and welcome to the session. In this session, this is the part 4 of clustering series where we'll be discussing what is linkage clustering, and we'll do a problem on that. So we have discussed different types of linkages in the previous session: single linkage, complete linkage, and average linkage. So we will be particularly dealing only with single linkage, also called as min algorithm, because as I said in previous session, in single linkage we will be finding the minimum distance between the data objects. So basically in hierarchical clustering, which we saw, which I have introduced in the last session, the link is given in the description box, where we produce nested clusters, and finally we'll be visualizing the clusters in the form of a hierarchical tree or dendrogram. So the idea behind single linkage is proximity among the clusters, right? So we find the proximity among the clusters in single linkage using the minimum distance algorithm. So we find the smallest distance from X, which is in one cluster, and Y, which is in another cluster. So we find the distance between two possible pairs of objects in two clusters, and then we merge them together. And basically the whole concept is very similar to a minimum spanning tree, which you must have studied in graph theory. So let's see a problem on this. So let's say this is the question, right? The sample data is given, right? And you have to apply the single linkage algorithm. Okay, so there are 5 objects here, 0, 1, 2, 3, 4, and the respective values of, for each object, the respective X and Y values are given. So let's do the problem. This is a given table. The first step is you have to compute the proximity matrix. I have to come up with a table called as proximity matrix, which I am doing using the Euclidean distance. So I am going to find the distance between 0 to 1, 0 to 2, 0 to 3, 0 to 4. Similarly, find the distance between 1 to 2, 1 to 3, 1 to 4. Again, distance between 2 to 3, 2 to 4. Then you find the distance between 3 to 4. How do you find the distance? Using the Euclidean matrix equation. Square root of, we have learned the equation in the last 2 sessions. The link is given in the description box. So let's say distance between 0 and 1 is square root of 1 minus 2 whole square plus 4 minus 8 whole square. So the value is 4.123. Let's see the distance between 0 to 2. Distance between 0 to 2 is square root of 1 minus 5 whole square plus 4 minus 10 whole square. So the value is 7.211. Let's say distance between 0 to 3. Distance between 0 to 3 is square root of 1 minus 12 whole square plus 4 minus 18 whole square. So like that, apply the Euclidean distance formula for all of them. And after you find out, you write this table. So this is our proximity matrix table. So how do you write the proximity matrix table? Is write all the objects on the x-axis and y-axis. Then inside you fill it up with the distance that you just calculated. See, distance from 0 to 0, 1 to 1, 2 to 2, 3 to 3, 4 to 4, it doesn't happen, right? Distance between itself is actually 0, right? So just put a dash here. Now, what's the distance between 0 to 1? 4.123, you fill it up here. Distance between 0 to 2 is 7.211, fill it here. Distance between 0 to 3 is 17.804, fill it. Distance between 0 to 4 is 27.295. Next, distance between 1 to 2 is 3.606. Distance between 1 to 3 is 14.142. Like that, you fill all the values which I just found. First, you put a dash, because distance matrix with itself is 0. It doesn't matter. So that means we will not have anything on this lower triangular. Only upper triangular will be filled. So that was the first step. I found the proximity matrix. Now step 2 is, what is the minimum distance? As I told you in the previous session also, single linkage algorithm is we find the minimum distance between the two objects and we group that together. That's the goal. Okay, find the minimum distance between the two objects, group it into one cluster. Now which is the minimum distance in this entire thing? 3.606. Therefore group 1 with 2. So you're going to make the items 1 and 2, cluster it together. Okay, that would be my step 2. So after clustering, see, this is before clustering, the same thing. Table 13.5, I have written it as it is here. This is my minimum distance. I am going to group 1 and 2. So after the clustering, how it is going to look? After this is my iteration 1. I am going to cluster 1 with 2. So how do you cluster 1 with 2? What we have to do is, you write the table. Okay, this is after clustering. You write the table. How do you write the table is, you write here instead of objects, before I was writing here objects, you write here now clusters. Then write 1 comma 2 1 comma 2 because I have grouped them together. So that means these two rows and these two columns I have to remove, and instead write the first row and first column as 1 comma 2. Write the other things as it is. 0 3 4 remains as it is. Just write 0 3 4 0 3 4. Now, how do you fill up this table? See, of course, distance between itself you put as dash dash dash. Okay. Now come to this. What is the distance from 1 comma 2 to 0? What do you find the difference from 1 comma 2 to 0? Write down here. Distance between 1 comma 2 cluster with the item 0 is, what is it? Minimum of the distance from 1 to 0 and minimum of distance between 2 to 0. You refer this table now. What is the distance from 1 to 0? See this. 1 to 0, here there is nothing. So see this one, 0 comma 1. Because I said in one of the sessions, it is symmetric. Proximity, one of the properties of proximity matrix is distance of I comma j is equal to distance of j comma I. This I have said in the first session. So that means distance from 1 comma 0 or 0 comma 1 both are same. So find the distance from 1 comma 0. So you can take 0 comma 1 then. So it is 4.123. Write that here. What is the distance from 2 comma 0? There is nothing here. So you refer 0 comma 2. It is 7.211. Right here. So what is the minimum of this? 4.123. Fill that here. Okay. Now find the distance from 1 comma 2 to 3. Distance from 1 comma 2 to 3 is, find the minimum of distance from 1 to 3 and 2 3. 1 to 3 is 14.142. 2 to 3 is 10.630. So which is the minimum? 10.630. So write that here. Similarly, find the distance between 1 comma 2 to 4. What's the distance from 1 comma 2 to 4? Minimum of 1 comma 4 and 2 comma 4. What's the distance of 1 comma 4? 1 comma 4 is 23.24. Distance from 2 comma 4 is 20.124. So minimum is 20.124. Fill that here. Next, find the distance from 0 to 3. What's the distance from 0 to 3? Refer this table. Put it as it is. 17.804. What's the distance from 0 to 4? Refer this table, previous table, 27.295. Fill it up as it is. Distance from 3 to 4. Refer this, 10.198. Fill it up as it is. So after iteration 1, this is my table I've got. So this is a table I've got after clustering 1 and 2. Now again repeat the same process. Which is the minimum here? From this table, 4.123 is the minimum, right? So 4.123 is the minimum. So that means what? 4.123 is minimum. So therefore I'm going to now cluster, I'm going to group 1 comma 2 with 0, right? So this is what we get after clustering 1 comma 2 with 0. Okay, so let's see this. See, this is before clustering, right? This is my previous table which I just got. I'm just copied the same table, right, after clustering 1 comma 2. So this is before clustering 1 comma 2 with 0. So after clustering 1 comma 2 with 0, this is what you get. How do you get this table? The same concept, right? Clusters 0, 1, 2, 2. Compare this table 13.6 with 13.7. What I am doing is I am clustering 1 comma 2 with 0. So write here 0, 1, 2. Write 3, 4 as it is. Same for the column. Now, how do you find the distance? Distance from 0, 1, 2 to 0, 1, 2 is dash. Distance from 0, 1, 2 to 3 is, how do you find? Find the minimum of distance from 0 to 3, 1 to 3 and 2 to 3. So what's the distance from 0 to 3? 17.804. Refer this table 13.6. What's the distance from 1 comma 3? Distance from 1 comma 3 is, you have to refer the previous table, this one. What's the difference from 1 comma 3? The first table that we had. Distance from 1 comma 3 is 14.142. The first table 13.5. Refer that and put that here. Okay. 14.142. Again, distance from 2 comma 3. Refer the first table 13.5. 10.630. Put that here. Okay. So which is the minimum here? 10.630. Put that here. Similarly, find the distance from 0, 1, 2 to 4. Minimum distance from 0, 1, 2 to 4 is, find the distance between 0 to 4, distance between 1 to 4, 2 to 4. Distance between 0 to 4 is 27.295. Distance between 1 to 4 is 1 to 4. Please refer the table 13.5 for this. Refer to 13.5 and fill it up. Distance from 2 to 4 is, again refer the table 13.5 and fill it up. So here minimum is 20.124, fill it up here. Okay, now this is my updated table after clustering 0, 1, 2. Now again find the minimum. The most minimum here is 10.18. Therefore, now this belongs to column row 3 and column 4. Therefore, I am going to cluster 3 and 4 together. Okay, so I am going to merge 3 and 4 together. So this is the table which I get after merging 3 and 4. So 0, 1, 2 is one cluster, 3, 4 is one cluster. So put a dash here. From 0, 1, 2 to 0, 1 to 2, put a dash. 3, 4, 2, 3, 4, put a dash. Now I have to find only one value. What is the distance between from 0, 1, 2 to 3, 4? Now, why there is a question mark is there is no need to find the value. See, we can find it, but it is not needed. We can find the distance from 0, 1, 2 to 3, 4, but it is not needed because this will not. We have reached the end of the clustering, right? Even if I find any value, there is nothing that I can do now. We have already reached there are no other items to be merged, right? We have reached it, and therefore, what are the clusters now? 0, 1, 2, and there is only one clustering that is left, that is 0, 1, 2, 2, 3, 4. Right? So that is why we have put a question mark here, because there is no need of finding the value. You can find, but there is no need, because the only clustering that is now left out is I have to cluster 0, 1, 2 to 3, 4. So basically, finally, this is the dendrogram that we come up with. So how do you come up with the dendrogram is refer the clustering. First we had clustered 1 with 2. So cluster that together. And what is this value? See, x-axis you write all the items. I have 0, 1, 2, 3, 4. Y-axis I am writing the values. So what are those values? If you see, I have grouped 1 and 2 together, and when I grouped 1 and 2 together, the minimum value was, go back and see, when I did the clustering of 1 and 2, when I had clustered 1 and 2, the value was the minimum distance for 4.123. So that is why here on the y-axis at 4.123, sorry, at 1, when I clustered 1 and 2, the value was, please refer the first minimum distance. The first minimum distance I got was somewhere on 3 point something. See, here it is. The first minimum distance I got was 3.606. So I have merged 1 and 2 at the value 3.606. That's what I have done here. Okay, merge 1 and 2 at 3.606. Then 1 and 2 cluster was merged with cluster 0. At what value? At the value 4 point something. That's why it is here, 4.1 something. Then I merged 3 and 4. When I merged 3 and 4, the minimum distance was what? 10.198. So that's why if you see here, when I have merged 3 and 4, I have done it at 10.198. So I hope you understood the significance of y value. Okay, clustering of 1 and 2 was done at around 3.6. Clustering of 0 with 1 and 2 was done at around 4.1 minimum distance, and 3 and 4 was done at a minimum distance of 10. Then finally this one, right? I merged 0, 1, 2 with 3, 4. Actually I didn't find this value, so just as an estimate, somewhere after 10 you can merge it. So this is the final dendrogram we obtained using single linkage algorithm. So that's it for today's session. Any doubts, please write to me in the comment box. Thank you so much.